Okay, here's quite a tough LCM and HCF question. The reason I think it's quite tough is because firstly, we're dealing with three different values here rather than just two. And secondly, we're dealing with algebra rather than numbers. So x equals ABC, y is equal to a squared, b squared, and z is a b cubed c. And a, b, and c are all prime numbers. So the first part of the question is we've got to find the LCM of x, y, and z. So the way I'll do that is to draw a Venn diagram. Okay, so the first thing we do is figure out what goes in the middle, and what goes in the middle is the thing that's common to all three of the numbers. So in terms of a's, they all share an a, so I'll put an a in the middle. X just has an a, so we can take that off. Y has another a, so we'll put an a here, and Z has no extra a's, so that's fine. Okay, we've dealt with the a's. B's, they all share a b, so b goes in the middle. X has no extra b's, so we can get rid of that. Y has an extra b, and Z has an extra two b's. So because Y and Z share an extra b each, we can put a b in the intersection of Y and Z. So we're done with Y now, but Z has an extra b, so we'll put a b here. So we're done with the b's, and then finally C. They don't all share a c because there's no c's in Y. X and Z share a c, so we'll put a c in the intersection of X and Z. So that's the Venn diagram done. To work out the LCM of these three, we'll multiply everything we see in the Venn diagram. So we'll do a squared multiplied by b cubed multiplied by c. So that's the LCM of x, y, and z in terms of a, b, and c. So I've just multiplied everything I see in the Venn diagram together. For part B, the HCF, well, the HCF is simply what goes in the middle section, and that is going to be AB. So that's the HCF. And for the third part of the question, we have to find the lowest possible value of the LCM, given that A, B, and C are all prime numbers and all different prime numbers. So I'm going to look at the LCM, a squared b cubed c. So we've got to assign them the lowest prime numbers. The three lowest prime numbers are 2, 3, and 5. Now we've got to decide whether A, B, and C are 2, 3, and 5, 3, 5, and 2, or so on. So I would say the one with the highest power, in other words the b, that should be the lowest of the three numbers. So b should be equal to 2. The second highest power, so the a, should be the second lowest prime. So we can say a is equal to 3. And then the c, with just a power of 1, can be the third lowest, which is 5. So if b is 2, a is 3, and c is 5, we'll plug those values in. So we have an LCM of 3 squared times by 2 cubed times by 5, and that gives us an answer of 360. So 360 is the lowest possible LCM of x, y, and z.